Hey everybody, we're winding down. Just got really one more brand new topic left, and we're about done. So we're going to get into that today. We're going to start with our first day of the Pythagorean theorem. That's how you say this. The Pythagorean theorem. Pythagoras was a mathematician. So he came up with this theorem that identifies and works on all right triangles. There's a relationship that happens between the legs and the hypotenuse of a triangle, of a right triangle. So when we're looking at a right triangle, first of all, what makes it a right triangle is the fact that it has a 90-degree angle. There's only going to be one of these. Okay, so there's a 90-degree angle, and it doesn't matter what the lengths of these sides are. Okay, but what does matter when we're talking about our equation is that the legs, the two shorter sides, the two sides that make this right angle, okay, the two sides that meet to make that right angle, they're A and B. Doesn't matter which is which, okay? A could be down here, B could be over there, doesn't matter. A and B are the legs. Doesn't matter which one you call A, which one you call B. It does not matter. But what does matter is that the hypotenuse is C. Okay, that longest side, the hypotenuse is the longest side of a triangle. And in a right triangle, it's always going to be straight across from the right angle. Okay, so when you're missing your hypotenuse, how do you tell if it's a hypotenuse? It's the side that's across from that right angle. Okay, the right angle is opening up to the biggest side of the triangle, and in that case, it is your hypotenuse. And we call that C. Why does it matter what letters these are? Well, the theorem, Pythagoras' theorem, is that a squared plus b squared always in a right triangle equals c squared. Here's why the letters matter. It doesn't matter which leg is A and which leg is B, okay, because you're adding them up. So the legs don't matter which order they are. You just have to make sure those are both the legs. The C has to be that value all alone on that one side of the equation. The hypotenuse is the longest side. That has to always be C, okay? So when we're getting into solving these today, you will always be finding that missing C value. You're always finding the hypotenuse today. So you don't have to worry too much about what variable you're missing. It's always going to be your hypotenuse today. So when we look at our first problem, okay, for the following right triangle, find the side length x. So as you notice, like we talked about, we are missing that longest side. It is across from the right angle. That's your hypotenuse. That's always your C. Okay, they're going to present it as x or any other variable. It doesn't matter what they're saying. But in terms of the Pythagorean theorem, a squared plus b squared, it always equals c squared. That's your hypotenuse. So your missing side today is the hypotenuse. Well, the a and the b, like we mentioned, it does not matter which one you call A, which one you call B. If we call 15A and 8B, you are going to substitute these in. Okay, so instead of A squared plus B squared, you're going to have 15 squared plus 8 squared, and that is going to equal your C squared. Your C is what you are looking for. Okay, so in case you don't have the squares memorized, 15 squared, or 15 times 15, is going to be 225. So that 15 squared is 225. 8 squared is going to be 64. Oops. Okay, so we had a glitch here. I need to erase a bunch of this stuff because, oops, because my recording glitched, of course. No, bear with me. I don't want to start the whole video over. So, okay, we're just going to leave that thing up there. Okay, so I accidentally clicked out of recording when I was right here. You don't have to worry about this thing right now. That's just something I'm going to talk about in a second. Okay, so where were we? 8 squared is 64. So again, if you don't know these squares off the top of your head, just go ahead and use a calculator. That's fine. So 64 equals c squared. And then again, if you're not sure, use a calculator for all this stuff. Now, Exponents happen first. This is just order of operations. So we got the exponents out of the way by squaring them. Now you're working on getting that c by itself. We're going to add these two together. So 225 plus 64 is going to be 289. Go ahead and use a calculator if you're not sure of that. That's just fine. Now, a big mistake that a lot of us make is that we think that 289 is the final answer because it's done. C is the only variable left, and there's just a number on the other side, but not so fast. We are looking for C, not C squared. Right now, this is C squared. That means C times C. We want a C all by itself. What is one individual C all by itself equal to? Well, we have to undo this squaring somehow. Okay, so that's what this thing is up here for. If you had 289 equals 2c, you would know that you have to divide by 2. Here, what's the inverse of squaring? The inverse of squaring is taking the square root. That cancels out squaring. That cancels out that squaring. So square root is the opposite of squaring. That's what you're going to do for your last step to get c alone today. So you take the square root of both sides. Again, if you are not sure what that is, 289 square root, use a calculator. It's going to be 17. So your answer, what is c, is actually 17 is equal to c. And that's why we have that written here. That's the length of your hypotenuse. Okay, one quick way to make sure if you got it right or wrong. Well, I should say one quick tip that's going to tell you if you did possibly something wrong or not. If you get an answer today, since you're looking for the hypotenuse, this is only when you're looking for the hypotenuse. If you get an answer that is smaller than one of the other two sides, if we would have got, for example, 13, there's 15 on that triangle that is bigger than 13. If you get an answer for the hypotenuse that is not the biggest side, you did something wrong. The hypotenuse is always the longest. Okay, so that's just one thing. Maybe if you make a certain type of mistake, maybe if you added wrong, or if you squared one of these things wrong, then you might end up getting something too small. But that's one way to kind of tip you off if you're going in the right direction or not. So that's one example. Okay, let's move on down to the next one. It's very similar, just two different legs. Okay, so we've got a leg of 15, a leg of 20, and then we're missing that hypotenuse again. Okay, that's your C. Doesn't matter what they call it. A, B, D, F, X, Y, Z, doesn't matter. That's your C because it's your hypotenuse. So for A squared plus B squared equals C squared, you are going to plug in 15 and 20 for your A and your B. Again, it doesn't matter. You could do 20 and 15, 20 for A and B for 15. Doesn't matter because you're squaring them and adding them. They're going to be the same thing either way. So we've got 15 squared plus 20 squared equals C squared. Again, sometimes one of the mistakes we make is that we just plug in 15 plus 20 and we say that that's equal to C squared. But we got to be careful because there's still this squared happening on the A and the B. You're not plugging 15 in for A squared, you're plugging it in for A. So you still have to square it. Okay, so it's 15 squared plus 20 squared equals C squared. All these things have to be squared in this theorem. So 15 squared, again, if you're not sure, go ahead and use a calculator. So 15 squared is going to be 225. So we've got 225 plus 20 squared is 400. If you're not sure, use a calculator. And C squared is still sitting there. These two things added up, 225 and 400. That's going to be 625. Still equal to C squared. Now again, you are not done. Do not think that 625 is your final answer because we still have to undo that squaring. How do you undo a square? The opposite of squaring is square rooting. That is the inverse. So you take the square root of both sides. Square root of C squared is going to be just C. And the square root of 625. Again, not sure off the top of your head. You don't have that memorized. Do it on a calculator. It's 25. A nice round number for ourselves. So 25 equals C. Again, we double check to make sure it's bigger than the other two legs. It is, so at least that part is right. And my answer is going to be 25. Okay, so that's all that I've got for you today because the homework is just 8 of these problems over and over. That's all it is. So if you want to pause and look at these examples or watch it a couple times, whatever, you're doing the same few steps over and over. You're always looking for that hypotenuse today. Okay? Good luck. Let us know if you have any questions, and we're almost done. Hang in there.